Now I am going to discuss the deducing the implied presence of symmetry elements from Cn and Sn. That means Cn as rotational axis of symmetry, it will give n number of symmetry elements when n is even or odd. That means C2 will give 2 number of symmetry elements, C3 will give 3 number of symmetry elements like C4, 4, C5, 5, etc. Where n is even or odd, it will give n number of symmetry elements. For example, Cn. It will give Cn1, Cn2, Cn3 and etc. Cn n minus 1, Cn power n. So, if one can have the doubt why it is not forwarding like Cn n plus 1. So, if it is proceeds through Cn power n plus 1, what will happen? We can write Cn power n plus 1 as Cn power n and into Cn power 1, right? And this Cn power n is E and this one is Cn power 1. So it will result finally Cn power n 1. Right, so this Cn power 1 already existed, so that we can't proceed through Cn power n plus 1. That means Cn can generate only n number of symmetry elements. Of symmetry, Sn can generate n number of symmetry elements when n is even. For example, S4 will give 4, S6 will give 6, S8 will give 8, S10 will give 10, like that. Okay. If we take example as S4, so it will give 4 number of symmetry elements. So S41, S42, S43, S44. Again we can write S41 as, so improper axis of symmetry Sn is Cn followed by sigma perpendicular to Cn, right? So that S41 we can write as C41 followed by sigma 1, right? So it results S41 only. Next, S42 will give C42 followed by sigma 2. C42 we can write it as C21 and sigma 2, that is n is even, so it will result E. C21 into E will result C21 only. S43, C43 sigma 3. That means here sigma 3 will remain as sigma only because n is odd, right? So C43 followed by sigma 3 will result S43. S44, C44 followed by sigma 4. C44 will result E and sigma 4 will result E. So that E, right? 1, 2, 3, 4. S4 will result 4 number of symmetry elements. If we see S6, again Sn can generate 2n number of symmetry elements when n is odd. That means S3 will give 6, S5 will give 10, S7 will give 14, etc. For example, if we work out about S3, so 3, this is odd number, right? So it will give 6 number of symmetry elements. S31, S32, S33, S34, S35, S36, right? So same, S31 can write as C31 followed by sigma 1, that is S31. S32 can write as C32 followed by sigma 2. C32 and sigma 2, n is even, so that it is E. Therefore C32. S33 can write as C33 sigma 3, right? So C33 will result E and sigma 3 will result sigma, so it will give sigma. S34, C33, C31 sigma 4, right? So S43. So S43 can write as C33, C31 sigma 4 because C34 can write as C33 plus 3 plus 1 C34, right? So C33, C31 sigma 4. C33 is E, C31 again sigma 4 will give E. So the resultant element is C31. S35. S35 can write as C33, C32, 3 plus 2, 5, right? So sigma 5. C33 is E, C32 and sigma. So S32. S36. C33, C33, sigma 6. So C33 is E, C33 is E and sigma 6. N is even, right? So E. So resultant element is E. So like that S3, so being odd number of symmetry element, odd number, so that it will give 6 symmetry elements.